Hello, everyone. This is Dr. Lennon, and we're going to look at Unit 1C today, sets and Venn diagrams. Sets are really just collections of objects that we list. They can be all sorts of things. They can be numbers, they can be words, they can be letters. And Venn diagrams are kind of a pictorial way to represent the relationship and if they have any intersection or not, just using kind of circles. A set, a collection of objects. Typically, we're going to write them in braces, separated with commas. And we don't list repeat items in a set. So the members are the individual objects in the set, and again, the sets are written listing their members within a pair of these braces, and they're separated by commas. If there's a pattern, sometimes in math we'll use a closed form to describe it that looks kind of like a formula, or possibly even a recursive formula. But a lot of times here we'll just use dots if the pattern's clear, right? If you have the set of all even numbers, you might write 2, 4, 6, 8. And then once the pattern is clear, you might just write comma, dot, dot, dot to indicate that pattern continues ad infinitum. And then the Venn diagram, we'll look at some examples, but basically it's just like a pictorial representation of the sets using circles and then a big square or rectangle to represent the universe of objects involved. Okay, so we're going to try to use set notation to represent the sets. So A, the set of all countries larger in land area than the United States, so that's going to be Russia and Canada. Sometimes China is listed as larger. We have almost the same exact area in terms of square mileage. Very, very, very close. But I think here they just do Russia and Canada. The set of natural numbers greater than 5. Again, natural numbers are just your counting numbers. So this would be 6, 7, 8, and so on. So they might do comma, dot, dot, dot after some amount that makes the pattern clear. So as stated, they have Russia and Canada inside the braces. And for the set of natural numbers, 6, 7, 8, and then the dots indicate that the list continues. Okay, so the Venn diagrams we write like this. Sometimes a set will completely contain something else. Sometimes they'll be disjoined. Sometimes they'll have some intersection, but not complete containment. So in the example above, we could consider the collection of the universe here, just all the animals. And we've got the mammals as one circle representing those. Non-mammals would be everything outside of those, outside of the light blue circle. And then inside the light blue circle, we have another one containing whales. So whales are a subset of mammals, right? There's all kinds of mammals that are not whales, but all whales are mammals, right? You have humans, you have cats, you have dogs, you have all variety of animals that are mammals. Anyway, so that's pretty clear. Yeah, so if a set is completely contained in another set, we call it a subset. So here whales is a subset of mammals. This one, again, we have all animals, and then we have fish and mammals. So there's no fish that is a mammal and no mammal that's a fish. So these two sets are what are known as disjoint. Yeah, they say disjoint. Sometimes you also hear disjoined. Both are used interchangeably. Excuse me. Here's a Venn diagram with some intersection. We have basically people and all their occupations. So if we consider the universe all occupations, we have doctors and then we have women. So those are two different sets of people. And there is an overlap because there are plenty of female doctors. So the overlap that is shaded by both the light blue and the purple circle, those are representing the women that are also doctors. Yeah. So that's the overlapping area or the intersecting part of those two sets. Yeah, so it says A may be a subset of B or vice versa. B may be a subset of A. That just means it's completely contained, as was clearly demonstrated in the whales and mammals example. Disjoint means they have no intersection, so they have no common pieces, and we saw that in the fish and mammals example. And then those that have some intersection, but one is not a subset of the other, those are sets that are overlapping. Okay, so describe the relationship between Democrats and Republicans and draw a Venn diagram showing the relationship. So basically, this should be a disjoint set because you can't be both a Democrat and a Republican at the same time in terms of being a member of one of the parties. And then there are also independent parties, so they should not represent the entire universe. So you should have basically the disjoint diagram we saw before. Yeah, independent and members of other parties. Yeah, so a person can only be registered for one party in the United States. Right, and we talked about the independent and people from other parties or people who are not registered would be outside the Democrat and Republican bubbles. Okay, draw a Venn diagram showing the relationship amongst natural numbers, whole numbers, integers, rational numbers, and real numbers. So natural numbers are the counting numbers. They're contained in the whole numbers. The whole numbers are the counting numbers with the addition of 0. Integers are positive, negative numbers and 0. So those are contained in there. Rational numbers are numbers that include all fractions, and real numbers are basically all the numbers that we study in like algebra. So they include rational, irrational, all those different numbers. So all of those numbers we see are properly contained in they're subsets. So natural numbers are a subset of the whole numbers, which are a subset of the integers, which are a subset of the rationals, which are a subset of the reals. Irrational numbers, those are contained. Irrational numbers are a subset of the real numbers, but they are disjoint from the rational numbers. Basically, the real numbers are made up of the rationals and the irrationals. So basically, any number that is outside the rational number bubble, but is inside the real number bubble is an irrational number. And we see all the other numbers that we saw were proper subsets of the others, as you can imagine. So sometimes they call this nested. The natural numbers are nested inside the wholes, nested in the integers, and so on, because it's just a complete chain of subsets. Categorical propositions basically talk about a subject and a predicate, and you have sets relating to each part. So one set appears in the subject and the other appears in the predicate. Let's look at this example categorical proposition. All whales are mammals. So whales are the subject set and mammals are the predicate set. And in this particular set, we know that the subject set is a subset of the predicate set. So sometimes they'll use letters to represent this, the subject and the predicate, S for subject and P for predicate. So, and sometimes they can do this in shorthand and it might look confusing, but sometimes the sets can be complicated. So instead of writing all whales are mammals, we can rewrite it as all SRP, because S is standing for whales and P is standing for mammals. So let's continue. All SRP, that's the example we just looked at. All whales are mammals. And again, like we said, the subject set is contained in the predicate set. No SRP, what would that mean? That would mean no whales are mammals. No fish are mammals. Okay, so they changed the subject on us, but this is certainly true. And this example is represented by those two disjoint pictures. The fish bubble that is completely separate from the mammal bubble. Some SRP, this would be an overlapping set. So what was the example of the overlapping set? I think they did women and doctors. Some doctors are women. You could do it the other way too. You could say some women are doctors. Some S are not P. Let's look at their example. Some teachers are not men. Certainly true. That's an overlapping set, and that's another way to say it. You certainly have female teachers. Some dogs can swim. Okay, so this would be an overlapping set, right? You have all dogs, and then you have things that can swim, and then you have the dogs that can swim. Okay, rephrase to some dogs are animals that can swim. Okay, then the Venn diagram, we have the big rectangle that represents all animals. You have the animals that can swim. You have dogs, and then there will be the overlap, which are the dogs that can swim. Yeah, so S are dogs, P are animals that can swim. Okay, so now we've got this as a categorical statement, and we can draw the picture. The dogs and the animals that can swim, and then the overlapping section is the dogs that can swim. Okay, so consider study summary lesson table 1.1. It's an example of a two-way table. The study was designed to learn whether a pregnant mother's status as a smoker or non-smoker affects whether she delivers a low or normal birth weight baby. The table shows four numbers which correspond to the four possible combinations of the baby's birth weight, status, and the mother's smoking status. So we've got a lot going on here. We have a two-way table. So if we look at the numbers in that table, the 18, that is the number of babies that have a low birth weight given birth by a parent who was a smoker. 132 is a normal birth weight whose mother was a smoker. The 14 is a low birth weight whose mother was a non-smoker, and 186 was the normal birth weight given by a mother that was a non-smoker. So that's essentially the list we're going to construct in part A, and then drawing a Venn diagram here, we're going to have different things in different intersections, right? We're going to have four bubbles. We're going to have the smoker bubble, the non-smoker bubble, the low birth weight, and the normal birth weight. And then we can kind of talk about the results there. So we did the first part, the 18 low birth weight smoking mother, 132 normal birth weight smoking mother, 14 low birth weight with a non-smoking mother, and 186 normal birth weight with a non-smoking mother. Okay, so here's how they've constructed the diagram here with just two circles. So they've got the low birth weight and the smoking mothers. So the intersection is the 18. So those were the low birth weight given by non-smoking. The 14 is outside that, which means there's a low birth weight, but the mother was non-smoking. The 132 is a smoking mother with a normal birth weight, and the 186 is everything in the beige outside of those two circles. So you can see how it's set up and how it properly describes the four different categories that we listed from the two-way table. So the Venn diagram makes it easy to see how smoking affected babies in the study. Notice the normal birth weight babies were much more common than low birth weight babies among smokers and non-smokers. However, the smoking mothers had a lower proportion of normal birth weight babies and a higher proportion of low birth weight. The study suggests that smoking increases the risk of having a low birth weight baby, a fact that has been borne out by careful statistical analysis of this and other studies. One thing I will point out, these diagrams are primarily visual and just show the relationship. They're not at all to scale. Notice the smoking mother's circle and the low birth weight circle are the same size, even though in the smoking mother's section, there would be 160 people represented. 150, 132 plus 18 is 150. And in the low birth weight bubble, if you added 18 and 14, that would be 32. So the size of the circle is not dependent upon how many things are actually in the circle. So there's not a notion of scale in these. So just keep that in mind. They're basically focused on showing how the sets interact and overlap with each other. Okay, three sets with numbers. So blood types. Human blood is classified according to whether three antigens A, B, and Rh are present or absent. Blood type is stated first in terms of the antigens A and B. Blood containing only A is blood type A. Blood containing only B is blood type B. Blood containing both A and B is called AB, and blood containing neither A or B is called type O. The presence or absence of Rh is indicated by adding either positive or negative, positive for present or negative in its symbol. So there are 8 blood types, and the percentage of each are shown in the next table. So let's draw a Venn diagram to try and illustrate this relationship. So we see all the different percentages there. The most common being O positive, and the least common looks like AB negative. So if we go over to the Venn diagram that we construct, let's look how we do this. We had to have 3 circles. So we've got A when A is present, B when B is present, and then the RH being when the RH is positive, meaning it's present. So we see that there are 8 different ways. Well, let's see, there are, so how many do we have in the diagram? So we have the A negative and the 8% region. So inside the diagram, there are 1, 2, 3, 4, 5, 6, 7 based on the overlaps, and then the outside area is the O negative. So anything inside any of the 3 circles has the right. It's kind of hard to describe this in words. That's why Venn diagrams are so useful, because they're much easier to just view. But you can basically see what's going on here. So inside the 3 circles, the only one that is the overlap of all 3 is the AB positive. It has A, it has the B, and it has the RH factor present. The A positive, working outside, is the intersection of A and the RH, the O positive, but it does not have any interaction with the B circle. Likewise, the B positive is the intersection of the B circle and the O plus circle without any interaction with the A. And then the AB negative is the intersection of the A and the B, but not interacting with the O or the RH circle. And then outside of that, they're on their own, right? You have your A negative at 8%, your B negative at 2%, and your O positive at 35%. And then outside, not intersecting with any of the circles, is the O negative. So those are the 8 regions that are represented in this Venn diagram. So anyway, that is it for Unit 1C. Again, Venn diagrams become easier as you kind of work with them, and they're visual to represent these lists, because you can see the different percentages, but not necessarily how they interact in terms of the blood types. So the Venn diagram gives a much better visual representation. And if you have a Venn diagram with only 2 categories, remember there's 3 possibilities. They could be, one could be a subset of the other, they could be disjoined, or they could have an overlap. So that's it. Have a look at the Unit 1C homework, and that's it. This is Dr. Lennon signing off.